Alright, so in this problem we're going to figure out the force again, the net force on a charge due to other charges. But the difference between this one and the previous one is that here the charges are not all along the straight line. Okay, so the process is going to be the same. Find the force on the charge that we're interested in due to the other charges, and then simply add them up using vectors. Okay, so the process is going to be straightforward, so let's make sure we understand and we take care of this. So the first part is in the problem we're interested in the 10 microcoulomb charge. Okay, so this is the charge that we're interested in right here. Okay, so what we'll do is we'll find the force on the 10 due to the 5 and due to the minus 2, write those forces in component form appropriately, and then do everything. Okay, so let's start. So the first step is going to be finding force between the 10 mu c and 5 mu c. Okay, the magnitude of that force, F1, let's call it F1, is going to be 9 times 10 to the 9 times 10 times 10 to the minus 6 multiplied by 5 times 10 to the minus 6, and you divide it by 0.75 square. Alright, so let's calculate this value, and what we end up getting will be, okay, so this value happens to be 0.8 newtons. Okay, also let's figure out the direction of this force. Since the 5 and the 10 are both positive, okay, this force on the 10 is going to be to the left, because this 10 is going to be repelled by the 5. So the direction of the force F1 is going to be to the left. So let's make sure we understand that. Okay, once again, the 5 and the 10, they repel each other, and so the force is going to be to the left on the 10 microcoulomb charge. Alright, so let's repeat the process. Oh yeah, so there's going to be 0.8 newtons to the left. Now that we have this, let us also write the force in vector form. Okay, since it's to the left, its x component is negative 0.8 and the y component is 0. So negative 0.8 newtons and 0 newtons. Great. Let's find the force between the 10 and 10 minus microcoulomb and the minus 2 microcoulomb charge. We call that force F2, and the magnitude of that force is going to be 9 times 10 to the 9 times 10 times 10 to the minus 6 times 2 times 10 to the minus 6 divided by, what is the distance? It's 0.5. Okay, so it's 0.5 square. Alright, let's calculate this number. So this happens to be 0.72 newtons. And once again, let's figure out the direction. If you look at the picture here, the 2 is negative and the 10 is positive, so we know the negative will attract the positive, and hence the direction of this force is going to have to be towards the 2. So this is going to be our force F2. It's going to point downward. Okay, so it will be pointing down, straight down, or along the negative y direction. And so now we can write F2 in component form, okay, as 0 comma negative 0.72 newtons. Great, now we have F1 and F2. The rest is very simple. Let's write Fnet. Fnet is going to be equal to the sum of the forces F1 plus F2 and this is going to be equal to negative 0.8 comma 0. Was it 0.8? Yeah. Plus 0 comma negative 0.72. Okay, when we add this up, we end up getting negative 0.8 comma negative 0.72. Now we can find the magnitude of this force, and the magnitude of this force is going to be equal to square root of 0.8 square plus 0.72 square. Now when you put these things in your calculators, I would recommend don't even include the negative sign, because I've seen a lot of people make mistakes with those things. Okay, because if you don't put parentheses around the negative signs, when you square them, they'll remain negative. It leads to all kinds of unnecessary complications. So just put the values 0.8 square plus 0.72 square okay, and then you end up getting the correct answer. You should get 1.076 newtons, okay, for the magnitude. Let us also find the direction. If you recall, direction is tangent inverse of the y component of the vector over the x component. Once again, we'll take absolute value signs and we'll put the appropriate quadrant, which is obvious in this case because the x and the y are both negative, and so my quadrant is going to be southwest or in the third quadrant, or you can give it an appropriate angle. So our values are going to be tangent inverse of 0.72 over 0.8, which happens to be about 42 degrees southwest. Okay, so understand the process. The process is very straightforward in this case. Find the magnitude of the individual forces, write them down in vector component form, add them just like we would add vectors, find magnitude and direction. Okay, so I know it's a lengthy process, but if you follow things correctly, you should be fine. All right.